Good morning, UKZN students and staff. Welcome to the industry talk hosted by the School of Chemistry and Physics. My name is Leena Rajpal and I'm the public relations representative for the College of Agriculture, Engineering and Science. I want to thank you all for joining us today. Most importantly, I want to thank our guests from Mintek who have taken time to come and present to our students and staff. I would now like to mention just a few house rules for the program. Firstly, the event is recorded. In terms of complying with the Boakye Act, kindly note that we'll use the information from the event for publishing purposes. Should you not want your information to be published for the purposes stated above, kindly send your concerns to rajpal@ukzn.ac.za. During the course of the event, all attendees will be muted with their video switched off. If you have any questions during the presentations, kindly post them in the chat box facility where it will be answered. During the Q&A session, the presenter will give you a chance to ask your questions. Please raise your hand so that the tech person can identify you and allow to unmute and pose your questions. If by any chance attendees interfere with the presentations, please note that your details will be noted and you'll be removed from the event. Finally, the recordings will be emailed to all attendees present and will also be posted on the CAES website. Without taking further or much time or any more time, I would now like to hand over to Professor Brenda Moodley, who is the discipline leader in the School of Chemistry and Physics.
Good day, everyone. My name is Professor Brenda Moodley, and I am an analytical environmental chemist in the School of Chemistry and Physics. So I'd like to welcome all our students today to this industry talk by Mintek. Mintek is an industry partner of the college, so we are looking forward to exciting and interesting talks telling us about the application of science in industry, and also for us to learn about some career opportunities at Mintek. I want to encourage the students to ask questions. There will be a Q&A session at the end of all the speakers. You can either type in your questions in the chat box, or you could put your hand up, and at the end of the session, we will unmute your mic and we will give you an opportunity to ask your question. I want to also say that we have 3 exciting prizes to give away to the students. So please listen carefully and type in your question or put your hand up to ask your question. You never know when the prizes will be given out. And without further delay, I'd like to invite Mr. John Neale, who will be our first speaker for today. He will present his topic on semi-passive biological treatment of acid mine drainage. Over to you, John.
Good afternoon, ladies and gentlemen. I trust you can hear me and see my presentation. Thank you very much for the opportunity to participate in your Tech Talk industry seminar series. My topic today is a pertinent one since it deals with one of the pressing problems of our time, the legacy of mining. I'm going to talk about one of those legacies, acid mine drainage, or AMD as it's known. In particular, about a biological process that Mintek is developing could play a significant role in mitigating the impacts of AMD in South Africa. Now, get right into it. AMD is news in South Africa at the moment, and I'm afraid the news is all bad. there have been some very recent high-profile instances of catastrophic releases of acidic waters into the environment, with impacts that will last for years and years. Now, AMD is an issue that has come to the forefront of people's minds only in the past 20 to 25 years, I'd say, as many of South Africa's coal and gold mines reach end of life, and with the realization that literally colossal amounts of tainted water are entering the environment and causing harm to the fauna, the flora, and to fresh water supplies. Solutions are needed urgently. Now, this map of South Africa is from the Water Research Commission's Mine Water Atlas. It shows all the mining projects for South Africa's major commodities. Dark blue lines denote our water management areas, and the light blue lines show our major river systems. The major risk in South Africa relates to the uncontrolled discharge of mine-impacted water from mine sites which are at or are approaching end of life, as well as from derelict and ownerless legacy sites, of which there are literally thousands. In this map, the gold reefs are depicted as yellow dots and the coal fields as grey dots. And you can see that they are mainly located in Gauteng and Western Mpumalanga. Coal fields are estimated to generate around 300 megalitres of AMD per day, and the gold mining areas are estimated to produce around 350 megalitres of AMD per day. These volumes are huge. Now, much of the water in the coal fields is characterized by having elevated levels of sulfate and iron and low pH levels. Most operational sites do have a neutralization or liming plant on site to increase the pH level, remove metals, in particular iron, before discharge. Some of the water that's released is suitable for use in irrigation, but water from the vast majority of sites requires treatment before it can be reused or released to the environment. Currently, the only commercially available treatment process to achieve discharge quality is reverse osmosis, or RO. There are a few RO plants in this area which are managed by groups of coal mining companies, treat mine water and produce potable water. The problem is that not all sites have or are linked to such a facility, and RO is expensive and energy intensive. We need more solutions to treat mine-impacted waters sustainably and cost-effectively to create a toolbox of technologies suitable for different sites and waters. So what do we have at the moment? Well, as I mentioned, lime neutralization, such as the high-density sludge process, is only partially successful in treating AMD. The main problem is that it has little impact on the sulfate concentration. It generates large quantities of sludge. As already noted, RO is a proven technology. It comes at a high cost and produces brines and sludges that are environmental problems themselves. In a water-scarce country, South Africa's discharge limits for sulfate are stringent, and they vary between about 200 and 600 milligrams per litre, depending on the particular catchment area. Biological treatment is an alternative treatment process that has potential application, particularly in post-mine closure applications in remote locations. These are two industrial examples of the established processes. On the left is the Wits Eastern Basin HDS treatment plant, and on the right is the Emelafleni Water Reclamation Plant, which is owned by Tungela Resources. It's notable that the effluent from the Wits Eastern Basin plant has to be diluted with large volumes of fresh water to mitigate the impact of the residual sulfate that hasn't been removed in the process. It's only a partial solution. Now, biological sulfate reduction is one alternative treatment process that has been successful in treating mine water in passive and semi-passive scenarios in several countries around the world. But it's worth noting that technologies that are successfully used for the treatment of mine water in other countries aren't always suitable for use in South Africa. And they often require some re-engineering, redesigning, and recosting. This is partly due to the quality of our mine water, specifically the high sulfate concentrations, but also because many of our mines are located in remote locations with little to no infrastructure. Electricity supply and roads are often no longer maintained after mines close. Security can also be a factor. So implementing biological sulfate reduction in South Africa is no exception. There have been one or two active and passive processes demonstrated locally, but they were not sustainable in the long term. There's currently one operating plant which is used for neutralization of acidic mine water and precipitation of metals prior to discharge. Mintek has spent the last 11 years or so developing a semi-passive process named closure to treat high sulfate mine waters. In fact, we were so enthused by the results we obtained that we trademarked the process as closure and created a logo by modifying our Mintek logo from pyrometallurgical stacks for clean water and crop clean. Closure is specifically targeted at remote sites with lower flow rates. So, as I've mentioned, this process is intended for mine sites with closure and is suitable for sites with limited infrastructure in remote locations, as well as for derelict and ownless legacy mine sites. The goal of this treatment technology is to produce water that is fit for reuse in irrigation in order to promote job creation, water and food security in a post-mining economy, to build resilient communities, and to protect the receiving environment. So what is this process? How does it look? It consists of two stages. Firstly, a biological sulfate reduction or BSR step to remove sulfate, increase the pH level, to remove metals. Reduction of sulfate results in the formation of sulfide, which can be corrosive to irrigation equipment and can pose a safety risk to plant operators. So in the second stage, the focus is on the biological removal of sulfide and residual metals and the production and recovery of biosulfur product. The integrated process is intended to produce treated water that is fit for reuse in irrigated agriculture. So a brief look at some of the chemistry of these two processes. The biological sulfate reduction reactors in the first stage contain a bed in order to provide a support structure for colonization by a diverse consortium of microbes. The microbes break down the available organic material into simple compounds such as volatile fatty acids or VFAs, which are typically the preferred substrate of the sulfate-reducing bacteria. Using a source of organic carbon, such as ethanol or acetate, using sulfate for respiration, sulfide and bicarbonate are produced, which drives up the pH level of the water and produces alkalinity. Sulfates are removed, and the sulfide produced binds to the metals in solution to form a metal precipitate, which is retained as a stable solid in the bed system. In the second stage, the aim is to cultivate a floating biofilm to oxidize all of the sulfide to sulfur to eliminate the sulfide problem. Typically, chemically and biologically, in the presence of high levels of oxygen, sulfide rapidly oxidizes to sulfate. And we want to avoid this since we've spent put a lot of effort removing the sulfate in stage 1. Now, when oxygen levels are low, typically less than 5%, sulfide concentrations are high, with a sulfide to oxygen molar ratio of about 10 to 1. Partial oxidation of sulfide occurs to produce elemental sulfur within the biofilm. These conditions also select for the sulfur oxidizers in the biofilm that are responsible for the production of biosulfur. Mintek designed and constructed a pilot plant with a nominal feed rate of 250 litres per day of acid mine drainage. This plant was operated at a local colliery in eMalahleni in 2017 and 2018. On-site piloting allows for the use of real mine water from sites which produce water that is highly acidic and has high sulfate concentrations. And the focus of this campaign was on the BSR, the first stage process. The plant comprised 3 BSR reactors in series, denoted as reactors R1, R2, and R3 in the picture. The conclusions from the first round of piloting were that sulfate reduction of between 97 and 99% was achieved, which surpassed our expectations quite considerably. Importantly, we detected no discernible impact of the winter temperatures on process performance. We noted that regular solid substrate replenishment was required to maintain process performance, but we also realized that replenishment of solid substrate is impractical at scale. We also found that most of the sulfate reduction occurred in the first reactor, which was an important finding. And equally, despite the high sulfates and consequently the high sulfide levels that were generated, there was no indication of sulfide toxicity impacting the process. The pilot plant was then moved to a new location, the eMalahleni water reclamation plant, close to where it had been previously. This phase of the R&D was to pilot the integrated closure process to treat AMD and produce water that would be fit for reuse in irrigation. First, the biological sulfate reduction, and second, sulfide oxidation, that being the integrated process. Also, the BSR reactors were reconfigured. The liquid organic substrate from waste materials was utilized in place of a solid substrate. This view of the pilot plant at the EWRP site shows the BSR reactors, two-stage system denoted R1 and R2 on the left, and the single-stage reactor RP. These two systems were operated in parallel. Then there's, on the right-hand side, the sulfide oxidation system in the greenhouse. The pH level of the feed water was between 2.5 and 3. So at the start of the project, the water was neutralized to increase the pH to a level of around 5. Once steady state operation was achieved, neutralization of the feed water was stopped and raw AMD was fed to the reactors. The feed water was pumped to 5,000 litre feed tanks together with a suitable source of liquid organic carbon and fed to each reactor system at a rate of 500 litres per day. By reconfiguring the BSR reactors and optimizing the provision of liquid organic substrate, the throughput through the plant was effectively quadrupled. The BSR reactors were operated for nearly 500 days, starting in December 2020. The sulfide oxidation channels were commissioned in April 2021, once sufficient sulfide was being produced, and operation of that plant continued for 340 days. Our operational team visited the plant twice a week for those 500 days and monitored flow rates, sulfate and sulfide concentrations, pH levels and redox potentials, electrical conductivity, alkalinity, and COD, chemical oxygen. Less frequently, the metals and nutrients concentrations were monitored as well. And I want to take you through some of the results that we achieved. This graph shows the sulfate reducing performance of the two CSIR systems. Startup for these reactors typically takes between 3 to 6 months. With the onset of colder winter temperatures last year, targeted sulfate production rates were not achieved, even though the operational data appeared stable. The country then went into lockdown during July 2021, so the plant feed was stopped until the beginning of August. With the warmer temperatures in August as we approach spring, and perhaps also due to the resting period, increased performance was immediately seen in both systems. Now, focusing on the period after the lockdown, it can be seen that both systems were at steady state and were producing high levels of sulfide, ranging between 600 and 700 milligrams per liter. In December, the sulfate concentrations in the feed water increased dramatically to around 5,700 milligrams per liter. This resulted in elevated levels of sulfate in the treated water from stage 1. This elevated sulfate removal would have resulted in increased production of sulfide. And if we had increased the amount of carbon source in the feed to the reactors, we may have achieved even higher rates of sulfate removal. It also produced enough sulfide to inhibit the microbes. However, during this time, iron in the feed also increased to between 1.1 and 1.6 grams per liter. And a mass balance showed that the corresponding decrease in sulfide at this time was due to precipitation of iron sulfide, which was retained in the bed reactor. Now, in this graph, the periods are divided into operational phases based on the feed sulfate concentrations. For the first 100 days after lockdown, an average volumetric sulfate reduction rate of 233 grams per cubic meter per day was achieved. With the elevated feed concentration, this increased to an average of 368 grams per cubic meter per day, and then decreased again when the sulfate concentrations returned to normal. The maximum volumetric sulfate reduction rate achieved was 458 grams per cubic meter per day. As mentioned, the quantity of carbon source in the feed could have been increased to allow the microbes to cope with the high influent sulfate concentrations. But without having all of the data on the feed metal concentrations available at the time, we chose not to risk sulfide inhibition and crashing of the system. Now, the sulfide-rich treated water produced in stage 1, shown in the previous graphs, was the feed to the sulfide oxidation channels. Prior to the lockdown, there was a decrease in the sulfide concentration with a corresponding increase in sulfate. A calculation of the molar ratio of sulfide decrease to sulfate increase indicated that the majority of the sulfide lost was oxidized to sulfate. However, after the lockdown, we observed a change in the molar ratios, indicating that less sulfide was being oxidized to sulfate. At the same time, we observed a healthy biofilm developing on the surface of the channels. The first picture is of the sulfox channels, and the second is a close-up of the biofilm in the first channel. After the lockdown, from about day 181, we started to see sulfate reduction in the sulfide oxidation channels with a corresponding increase in sulfide. On day 216, sulfide was removed while sulfate levels remained low, and the biofilm began to thicken, indicating that sulfide was being partially oxidized to sulfur. Up to 76% removal of sulfide was achieved in the channels, and the biofilm contained up to 60% elemental sulfur by mass. Next, the period when the AMD feed had the high levels of sulfate and iron was experienced. During that period, there was little to no sulfide increase in the channels. This is because the excess sulfate not removed in stage 1 was reduced here, producing excess sulfide, meaning the biofilm was removing all of that excess sulfide. When we accounted for the excess sulfide produced, we continued to achieve approximately 70% removal. Once the AMD feed returned to normal, 31% sulfide removal was achieved. And it's a pity that the operational period ended at that point, because the sulfide removal may well have improved once again. Finally, this table compares the metal concentrations in the feed and after the water has been treated in the process. Red cells show where the feed water exceeds the Department of Water and Sanitation's target water quality range, or TWQR. So there are only a few metals of concern in the feed water. After treatment, the water met all of the DWS irrigation standards for metals shown by the green cells, with the exception of manganese. When the iron concentration was above 1,000 milligrams per liter in the feed, the effluent iron concentration was 0.3 milligrams per liter. Now in this table, you can see the removal of 98% sulfate and an increase in the pH level and alkalinity. Nutrients in the treated water are higher than the TWQR, suggesting that further optimization of nutrients at scale is required. We are consulting our partners at the University of Pretoria, who are doing a more detailed analysis of the water quality using the so-called decision support system model, which takes into account rainfall, soil type, and tends to be a little more lenient when considering parameters such as manganese, alkalinity, electrical conductivity, and nutrients. So what were the conclusions from this round of piloting? Well, the treated water meets the TWQR in terms of the department's guidelines for irrigation. We removed 98 to 99% of sulfate and metals of concern. We achieved up to 76% removal of sulfide, but we noted that the effluent concentrations were not consistent. Based on available literature, we think the design needs further attention, with the aim of contacting more of the water with the biofilm and the oxidation zone. The biofilm is also very susceptible to the elements, and strong wind and rain can damage the layer and cause the solids to sink and be retained in the system. Of course, covering of the oxidation ponds at scale is not likely to be feasible. So while we feel this study was a success and the process treated the water effectively, there is still work to do to achieve sufficient oxidation of sulfide to sulfate. As mentioned earlier, further optimization of nutrients at scale is also needed. What are the next steps? Well, one of them is to undertake a market analysis for the biosulfate product. Our initial indications are not that good. In fact, they are that there appears to be sufficient sulfur for most crops in Mpumalanga. And we have been advised that it isn't necessary to add a sulfur product with fertilizer to, believe it or not, excess sulfur dioxide emissions from all the power stations in the area, which is a whole other problem. Going forward, the next step in our process development is to scale up the process to treat 50 cubic meters per day of water. We've received funding from the Technology Innovation Agency and formed a consortium with our partners Thungela Resources, the Moss Group, and the University of Pretoria. Thungela has funded and constructed the demonstration plant, shown there, the Eminent water reclamation plant, and Mintek is also funding the operation and maintenance of the plant. The aim is to demonstrate closure technology at 50 cubic meters per day for the next 2 years, and to integrate the process with irrigated agriculture with our partners from the University of Pretoria. The plant is expected to be inoculated next week. Outcomes from this will include detailed economic evaluations, culminating in the design and costing of a commercial scale plant. To conclude, I do want to acknowledge our partners and our funders. Over a long period of time, there have been a lot of them. Current consortium of Tungela, University of Pretoria, the Moss Group, funded by the Technology Innovation Agency, is going to be taking this demonstration scale project forward. And finally, I want to acknowledge some of my colleagues who have been involved in this project for a considerable amount of time. A project like this is complex and it's a logistical exercise, especially when you consider that Mintek is located in Randburg. It's about 150 kilometers from Llewelyn. And there's some extraordinary people that I work with on that list. And my thanks to them for their contributions over a long period of time. Thank you.
Thank you so much, John. That was a very interesting presentation, and thanks for sharing the research work that you're carrying out with acid mine drainage. It's such a huge problem for South Africa, and coupled to that with the reclamation issues of water, that was very interesting work to listen to. Thank you very much. And we'll move on to our next speaker today, and that is Ms. Gladys Boakye. And Ms. Boakye will talk to us about the world is changing and so is Mintek. So over to you, Gladys.
Good afternoon. Good afternoon, everybody. John, thank you very much for the presentation on Mintek to our students here and the department. I wanted to say to yourself, Leena, thank you so much for organizing this session and allowing us the opportunity as an organization to interact with your students, and also just introduce ourselves in terms of the benefits and who we are as an organization, which I'll talk to, and very importantly, what are some of those programs that students can tap into. So as already mentioned, my name is Gladys Boakye, and I am the Organizational Development Specialist. So I'm an OD expert. I look after learning development and organizational development for Mintek. I am based in the Human Resource Department, and this is where some of these programs that I'm going to talk about are based. Before we start, and I go into my presentation, I am going to share a screen and take you to a video on Mintek about our organization, and it's just a mini induction for yourself, or mini introduction of ourselves to you, and then after I'll go into my presentation. Thank you.
With most of the world's platinum and chrome, over a quarter of its manganese and a substantial proportion of its gold, South Africa is a country blessed with mineral resources. Unlocking wealth from these resources over the past century led to South Africa's success and made it the economic powerhouse of the African continent. The key to this wealth is held by an organization with a legacy of mineral expertise stretching back more than 80 years. It's a legacy that has resulted in unique proprietary products and technologies being used all around the globe. That organization is Mintek. Today, Mintek, situated in Johannesburg, South Africa, is one of the largest and longest running minerals technology facilities in the world. With a staff of around 700, including 250 scientists and engineers, Mintek provides minerals technology and expertise to international companies in the metallurgical, medical and nanotechnology fields. Separate divisions within the organization focus on technologies that improve the efficiencies of mining and industrial metallurgy. Technologically advanced laboratories working with the world's largest metallurgical research database refine and develop mineralogical processes. 3D imaging of samples using tomography is used to extract quantitative parameters from minerals. Mintek's Analytical Services Division, with state-of-the-art instrumentation, specializes in geochemical and metallurgical analysis. The Minerals Processing Division within Mintek develops process engineering solutions that maximize the recovery of minerals from a large variety of ores. All the equipment needed for test work from early-stage development to large-scale continuous production is available. Research and testing is done on mineral extraction methods such as bulk crushing, milling, magnetic or gravitational separation, and flotation. As world leaders in the separation of platinum group metals, gold, chromite, iron ores, phosphates, graphite and uranium, Mintek has patented numerous technologies that are now used around the globe. The extraction of metals from ore using fire is a technique that is thousands of years old. Mintek's Pyrometallurgy division is focused on refining this ancient technique for the modern age. Development of Mintek's patented smelting technologies using DC arc furnaces started in the 1970s, and today Mintek is a world leader in the technology. 4 on-site furnaces of different sizes are available for test campaigns extending weeks or months. Mintek's in-house multidisciplinary team of metallurgists, earth scientists, engineers and chemists can address all pyrometallurgical challenges. Technology developed by the team has been used for the production of numerous commodities around the world. These include ferrochromium in South Africa and Kazakhstan, the recovery of cobalt from slag dumps in Zambia, the production of ferronickel in New Caledonia, and battery recycling in Switzerland. Mintek's Hydrometallurgy division focuses on using aqueous chemistry for the recovery and purification of metals from ores or concentrates. Some of the technologies developed by scientists in our pilot plants include the Matrix resin in pulp technology, as well as the patented Savman acid mine drainage treatment technology. Work is currently underway to integrate hydrometallurgical techniques for the extraction and separation of rare earth elements from various sources. Many of the processes developed by Mintek can be integrated to treat contaminated water and waste streams. Scientists and engineers in Mintek's biotechnology division have over the past 35 years developed bioleaching technologies to extract gold and base metals from sulfide ores and concentrates. These technologies have been implemented successfully across the world, from Tasmania in Australia to China, from Mexico to Iran, and most recently in Finland. To ensure that processes developed in-house are reliable, a specialized division within Mintek, focusing on measurement and control, has patented numerous technical solutions. These advanced process control systems ensure that the technologies Mintek produces run reliably in the field. In 2007, Mintek's 8 decades of research resulted in the formation of the DST, Mintek Nanotechnology Innovation Center. This collaboration with the Department of Science and Technology focuses on the research and development of materials for water treatment membranes and health diagnostics for HIV and TB. In collaboration with the University of Cape Town, the HISA Catalysis Center of Competence has been established within the Advanced Materials Division. The center researches hydrogen catalysis, components and systems for fuel cells, along with international industry partners. The goal is to add further value to South Africa's mineral wealth and establish the country as a global exporter of catalysts and fuel cell components. As a state-owned organization, Mintek strives to ensure that the research done in-house benefits smaller companies as well. Communities across South Africa are being trained in small-scale mining and the manufacture of jewelry, semi-precious gemstones, glass beads and pottery. Building on our long and rich heritage, Mintek aims to continue improving on the quality of work that we produce for clients across the globe. Through developing our human capital and organizational skills, we will cement our position as global leaders in mineral and metallurgical innovation.
All right, thank you very much. I'm going to go into my presentation. If there are any questions, I'm going to ask that you please put them in the chat box. As indicated earlier, my theme for our conversation is the world is changing and so is Mintek. So as an organization, we adopted this theme prior going to COVID, and basically just the constraints that COVID had placed on organization, we needed a mindset change. So the mindset change really adopted then what we call now our Mintek Strategy 2030, which was as a result of organizational diagnostics. So these organizational diagnoses had positioned Mintek to the future. So what does the future look like? And very soon, I think, we've got plans. We are working on our culture as an organization, improving our culture as a result of the Strategy 2030. And very soon, I think that theme of the world is changing. The world has already changed. So our theme is different. And, we talk about Mintek being a global leader. Indeed, that is what we are. And I'm going to just share my presentation, talk a bit more about our culture, talk about our values, our vision, and then go into the programs that we have in the organization, which yourselves as students can tap into. I'm going to unshare my video. All right, thank you very much. Okay, so Mintek at a glance. Our vision as an organization is to be a global leader in minerals and metallurgical innovation. And you will see from the video that you just had that a number of the products and the services that we provide have been consumed worldwide. And we continue to do that. That's our trajectory. In fact, in terms of even our postdoctoral, and I'm jumping the gun here, going ahead, in terms of even our postdoctoral programs, we, not only advertise nationally, regionally, and internationally. We are interested in as much as we have got MOUs across the nation. We've got products across the nation that we also tap into global talent as well. Our vision is to serve our stakeholders by adding value to the mineral resource through technology, industry growth, human development in a sustainable manner. So human development as far as the capability of our employees are very important to us, but also how we invest in those who are currently in academia is also very important to us as well. So our objectives is to develop efficient mineral processing technologies, ensure that we've got sustainable value products and services, and support the second economy interventions, human and organizational development, and as an organization, we drive good governance. Our values is we are creativity. This is where I think our drive to build innovation comes out of. And when you go through our Strategy 2030, it talks a lot about innovation. So that is what we are when you come into Mintek. We want an organization, or we build an organization, or we are employees that are very innovative, and our products and services speak to that as well. Our teamwork, we value teamwork. So when you come here, we've developed a structural organization that is clusterized based. So very much talking about a matrix structure whereby you are able to tap into skills and capabilities that are in other departments or divisions as well. So we develop an employee to be able to be diverse, apply themselves, know the organization, understand the organization, our services, and how then, the value we add to the communities and nationally and the world in total. Our performance as an organization is top priority to us. As an organization, we believe that every employee is a leader, meaning that in that corner that you are, regardless if you're the cleaner to the gate, you are a leader. And your leadership capability should be seen in the quality of the work that you produce in the organization, because this is what enables us to excel as an organization. We're a diverse organization. We're an organization that respects our values, the values that I'm talking about here, because that is what governs us. When you walk through the Mintek gate, regardless of what your personal affiliations and biases are, these are the values that we are subscribed to. And we are an integrous organization as well. So Mintek, in terms of our priorities, in our key priorities is that we conduct research and applied research and produce technological innovation. But we also support in the establishment of new industries, and we collaborate with existing industries to see how they can, in terms of longevity and in terms of impact, they are able to make greater impact in their longevity. We develop our capable workforce internally. And as I mentioned, we also have investments in those who are studying, also in terms of offering bursaries and offering vocational opportunities for those who want to come and have some experience or understand as to what we do. I'm jumping the gun, but we also have this relationship with universities whereby, when universities want to, as of when, they have a tour of our facilities and get to understand and go into our facilities, see our technologies and see our products and interact with that. This is something that happens quite often as an organization. And if yourself, the students, have not had that, please speak to the powers that be in your department, and we would love to host you here at Mintek. We also then ensure financial sustainability as an organization. That means that, as an organization, it's important that we believe in happy employees, remuneration, and those that, are even outside and getting bursaries, are able to cater, and it's conducive for them to, achieve the goals that they want to achieve as per their academic aspirations. And we develop and maintain world-class operations and ideas. So our focus has been really honing in our RDI expertise and in terms of our research outputs. So we have, increased our research outputs, and us going to the market and looking for suitable postdoctoral fellows is to plug them into these areas whereby they can focus on research, quality research that is, world-class and that is globally competent. So our value chain as an organization, we don't own mines as Mintek because of our work with mining institutions. A lot of people think that we don't own mines. We are a state-owned entity. And what we do is, yes, we've got exploration, we've got mining in terms of our relationship, but the biggest part of our value chain, which is our key focus areas, is the concentration, extracting, refining, manufacturing, and post-mining. And this is where we plug in our expertise to ensure that in the industry, internationally and locally, these areas are able to produce good returns for both the company and the nation as well. So our values, I mentioned our values says that we are global leaders. When you go through the world and in terms of what we have developed and plugged in around, our products are all over the world. If you see the global depiction here, this is where you would find Mintek interacted products. I think as far as, if I'm not mistaken, 2013, we actually also had a Mintek office in Australia also, which, currently there's plans to resuscitate that office. So we are globally positioned and our products are consumed all across the world. And these are the products that you would find in terms of their usage globally. Let's talk about then the programs that we have, which I think then you are very interested in. We have a number of programs that you can tap into. I think I mentioned that we are on a path and we are strengthening our science, engineering, basically our technical capability. We are strengthening our technical capability. We recently had an induction, and then the CEO was saying that, you know, about 3 years ago, I think it's post-COVID, when you get to the gate of Mintek, you can literally smell science, you can smell research, and post COVID, this is what we are all about. We are honing our research capabilities and how to leverage, you know, postdoctoral candidates to and interns to increase our research output. So in that regard, then, you know, we ensure that there is research funded and bursaries available to both internal staff as well as external as well. And maybe let me just give you a small bit of a glance. We do have bursaries for full-time students, and we have scholarships as well. We have got internship opportunities. We've got VAC work opportunities as well. We've got what you call graduate into training as well opportunities, and we've got postdoctoral opportunities. I think sometimes some of these things also depends on the type of MOU we have in an organization. As much as we do advertise these things and we give calls, we open calls for these things, depending on the MOUs that we have with the institution and the areas in which they want us to support them. You know, they would be our first area of reference when these opportunities and, you know, open in terms of application. For example, we have a relationship with TUT, and in a year we are invited there to go and present to their chemistry department, and, you know, ensure that they also have first-hand information as to when our application is open. And I think these are conversations that we're definitely going into with the institution, providing that information for you. And when we have these applications open, which is now closed, we open in March, you have the information to be able to put yourself forward. Okay, so apart from the fact that, you know, our research outputs and our capability, competencies, and all of that are top-notch priority, our performance is, you know, quite important. I mentioned there that we're diverse, and, you know, one of our values is to be diverse and serve with integrity. So when you come into human resource, we have been driving our stats, and our focus has been on our master's and doctorate output. So even internally, you know, every employee that does not have a master's or PhD, we are funding that. We want everybody here in Mintek, you know, to have masters and PhD. So we fund that, and we are interested in, I think, first priority, second priority goes for your doctorate, your masters, and your honors students. So if you have a master's now, you're a postdoc now, you know, would love to have a conversation with you. We have a postdoctoral applications that are open, and on our site, you can go and have a look at it. And if you want to apply, it's a 3-year program, greatly funded, paying quite well in terms of remuneration. I would love to have that chat with you if you are in these categories as well. So when you look at Mintek, this is how we look as far as our key competencies are, how we are spread across. In terms of our key competence, you see that the chemical engineering unit forms one of the biggest part of our staff complement as well. And as far as our gender and our diversity profile, this is how, you know, we look as an organization. No, not gender. I think that's what I'm going to. So we have then, you know, in the organization, we have more masters employees, and if you see gender, you will see that the majority then of our females, you know, hold a master's in that area. And even in the PhD, it has improved, and even this stat has improved, and even in the PhD area, you'll see that the majority of our females hold the most PhDs. Okay, let's go ahead. So we have the science vote is something that we run internally, and basically it talks about, it's a funding opportunity whereby we fund new technology research and the continuation of research. We also have then for the science folks, we look at in terms of the funding areas. This is how we have structured the funding areas for the science folk program. Okay, so as an organization, when we talk about gender and being diverse and promoting that, so currently, we are pushing the stats of having more of our females. I think we stand at the moment, we stand about close to 50% of having the majority of our females, being technical and scientists. So previous COVID times or previous COVID times, we had the balance has been more males than females, and in terms of the technical area, we're pushing for more female engineers, and we are achieving those targets. So if yourselves ladies here who are quite interested in joining the Mintek with your engineering technology qualifications, we are interested in those. So that is it. As I mentioned, let me just go over the bursary opportunities that we have. So we have bursaries starting from second year students that have got 60% with their their subjects or their majors in science, engineering, and in chemistry. These bursaries cover all payment of your registration, your tuition, your accommodation, your meals, and also you are also given an annual balance as well. And in return to this, Mintek would have a year an agreement with you to come and then work at Mintek as well. We have undergraduate bursaries also, to vocational work. So we do have students from TVETs that would apply to do vocational work. We do provide that as well. Our internship programs, we have internship programs also in the various divisions in organization. And if you want more inquiries on this, I'm going to ask that, I think our information is going to be provided, but I ask that you contact me, gladysb@mintek.co.za. Thank you very much.
Thank you so much, Gladys. That was a fantastic presentation, and you've given us some really great information on how to contact you and the bursaries that are available, as well as the vacation work and so on. That was excellent. I'm going to go on to our final speaker for today, and that is Mr. Taswald Llewelyn Moodley. And he's going to share his presentation on his career journey since graduating from UKZN. So over to you, Taswald.
Okay, thank you for the opportunity. I trust that everyone can see my screen now. So my short talk will be on my career journey since graduating from UKZN. And I've even remembered my student number, so I've put it on my slide there. Okay, so I've structured my talk in several periods, starting from 2007, when I entered the university, and then subsequently doing my master's, followed by several roles within Mintek, and then ultimately coming back to UKZN to do my PhD, followed by my current role. So importantly, the first stage I won't talk about too much, because all you need to know there is that I had to take a 250K loan, student loan, to study. So let's pick it up from the time I'm doing my master's. So I studied for my master's under Prof. Brian Loveday, and he happens to be a Mintek employee. So hint, it helps to know people in the right places. So at least he could structure my master's topic so that it made my application for my Mintek bursary more positive. So I did my master's in flotation, and this is a physical chemical process of separation of platinum minerals. The platinum industry is very big. It's 190 billion rand a year industry. And for those postgrads that are watching, or undergrads who couldn't get a job, pick a master's topic or an industry that has lots of money. It's easier for you to get funding, and it makes you more relevant after you finish. So it also makes it easier to get a job as well. So then moving on, once I graduated with my master's, I enrolled for the graduate development program at Mintek. So as Gladys says, they usually absorb you once you're done. And this involved rotating through the 9 technical divisions, which, as Gladys described, have various types of metallurgy departments. So importantly for the students that are watching this presentation, during this period, I had to pay back my student loans at a rate of about 7K a month, which is a 3.5-year payback period. So it was like paying a car installment for those years. Once I graduated from the engineering training process, or the graduate process, I started work as an engineer in the flotation department. So what was my daily life like? Well, it involved developing processes or developing flow sheets to process commodities like platinum, gold, copper for clients around the world. It's nice that I was placed in the flotation department because of my master's. I had a very good standing in the field. So it made things easier. Also, there was opportunity to present at local and international conferences. So for those of you who struggle to get funding at campus, at least if you choose the right job after, there can be potential to get money for that. However, the major problems that I found while working. So I noticed that the empirical work or the empirical solutions that we proposed, they were limited. Meaning, for example, if a client came in the past to do work, and then suddenly they come now and the feed grade changes, then the old routine processes, they struggle to give an answer. And so that's because of the complexities in the ore bodies. And so many of these problems can only be unpacked through immeasurable information. So things like stress and strain are difficult to measure in situ. And so I had decided that one would need to undertake a long-term study to solve this problem. And that brings me to the next phase of my career. This was between 2017 to 2021, where I was granted sabbatical leave from Metallurgy to undertake a full-time PhD under Prof in Governor, who is a professor of particle physics at UKZN. So Mintek also offers that, where they can grant you sabbatical leave in order to pursue full-time studies. However, for those students that are watching this presentation, this implies that I had no salary, which was really bad. But I was a student bursar, so I had to adjust my living, my lifestyle to accommodate for my student bursar. On the positive side, I worked on modeling tumbling mills. So this involved simulations, computer simulations, and these were validated by nuclear experiments. So quite simply, these tumbling mills just use steel balls and water to grind or liberate valuable minerals from rocks. So why did I study this? Well, they're very inefficient. They use less than 10% of the total energy supply for breakage, meaning they waste 90%. And they're equally very expensive. So catch this one, they use 5% of SA's total energy grid. Yes, that's right, 5% of SA's total energy grid is just used for tumbling mills, not mining, just the tumbling mills. So this is, for those of you who are thinking of postgrad studies, this is why it is an attractive research topic for funders. And for my efforts during my time at UKZN doing my PhD, I managed to win a couple of awards. So I was in the 2020 UKZN PRIS. I won first prize in the oral for the PhD category. And I followed that up in 2021 by being acknowledged by my peers for most impactful research. So this brings me to my current role. What am I doing right now? So I'm currently a senior researcher in Mintek, and I provide modeling and simulation solutions to 3 different divisions, namely the mineralogy division, minerals processing, and analytical services. So this entails developing solutions using open source and licensed software. One of the perks of me having completed my PhD is I get the opportunity to present at global physics and minerals processing conferences. For example, in 2022, I presented at a physics conference in Yokohama, Japan, and a minerals processing conference in Melbourne, Australia. So I'm currently registered as a candidate engineer at EXA, and I'm also registered as a member of CSIR. Lastly, takeaways from my talk. For the students, don't give up if you don't have funding. Remember, even taking a student loan, it might seem like a lot of money, in my case, 250K, but these are minor setback. And when you think back, you'll realize that it's about that sacrifice initially, and things have a way of working themselves out. Also, not having a job after undergrad is not the end of the world. The postgrad route can be equally rewarding if you choose your topic and supervisor wisely. I always would suggest to go and work first to find yourself, understand your strengths, understand your weaknesses. And lastly, I'm going to leave you with this nugget. If you don't buy a ticket, you can't win the lotto. In other words, don't be scared to take a risk. But by taking a risk, it usually implies sacrificing, for example, in my case, my salary. But I'll leave you with this one thing, that if you chase your dreams, money will follow you, not the other way around. So with that, I'd like to thank you. These are some of my contact details for any students that need advice on careers or just want to contact me in general. I'll be more than willing to assist you guys. So thanks.
Thank you so much, Taswald, for that really inspirational talk and for sharing your personal journey with the students. That was very, very useful for our students. So I'm going to open up the session now for some question and answers. So students, please put your hands up and we will go to you. I see the first speaker, the first person who's put his hands up is Mpho. Mpho, I think, are you unmuted?
Okay, finally I'm unmuted. Good day. My question is based on, here's my question. Does Mintek do background checks, like things like criminal background and those things, before they take on a student or hire anyone? And if you do criminal checks, do you hire people with a criminal background or not? If you don't hire them, what's the reason not to hire them? And then my second question is, I see on the presentation of the lady there, she mentioned that their drive is to get more females into the roles. What is the reason for this? The reason I'm asking this question is because I can imagine that some boy child who's born in 2005 is now not given an opportunity at Mintek, so simply because he's a male. So what is the reason behind all that, given that the current cohort of the students that we have, which will be possibly people who are born in the year 2000, they had no decision in whether the females should be held back in careers or not. So that's my questions.
Thank you, Mpho.
Thank you. Do I answer the question? Excellent. Thank you very much. Thank you, Mpho, for the question. So yes, definitely, it is part of our recruitment policy that background checks are conducted. I think this is a worldwide, I don't want to say phenomenon, but it's a worldwide accepted practice when you are recruiting. Also, maybe it came out differently. I think it is to promote women in engineering. That is the policy. It's not saying the boy child is excluded from the opportunities. We're saying as an organization, if you are female in engineering and you are aligned to our core competencies and you know what we want to invest in, we would invest in that. But of course, it's open to everybody. And what you call it, it's open. You know, you would not be discriminated because you are a gentleman or a guy or male. No, we are promoting women engineering. We are promoting men engineering. We are promoting engineering in total. We are promoting our key competencies. That is what it's about. Thank you.
Thank you very much, Gladys, for answering that question. I can't see any other hands, but I'm going to go to the questions in the, Mpho has a follow-up question. I'm going to give you a chance, Mpho, before I go to the chat box.
Oh, I was just saying the lady didn't answer the question about the criminal backgrounds. Yes, she said they do criminal background checks, but she didn't say whether someone with a criminal background can still be hired or not.
Gladys, do you want to?
Yes, I do want to answer that. Thank you very much, Brenda. So I think that's, you know, that is not an area of contention for us. Definitely as an organization, we don't want to, we wouldn't, our first preference would not to recruit a person with a criminal record. That would not be our first preference. But of course, I think, you know, wisdom applies when we are recruiting, and we look at what type of criminal offense it is. What type of criminal offense is it? Was it skipping a red robot? Or was it something that maybe it's, what do you call it? With regards to having debts that were not paid and something, you know, something was generated out of that. Yes, if you murder something, that's a serious criminal reference, what do you call it? If it was theft, yes, definitely serious. So our first preference would not be to recruit a person who's got a criminal background. Thank you.
Thank you, Gladys. I'm going to go to Becca because she's posted a question online in the chat box, but she's going to ask her question. So Becca, go ahead and ask your question.
Good day, everyone, and thank you for the next presentation and the opportunity to ask my question. So as I was listening to Dr. Moodley, and he was expanding on the advantages of doing postgraduates, and also on the presentation on how the postgraduates are being hired or enrolled to be part of the Mintek company. So my question was based on, does the company or Mintek consider a topic of research when they are hiring? Whether is it like in line with what you are producing or what the company is doing? For example, if let's say a candidate is doing chemical engineering, but maybe the topic, let's say, is different from your technologies or products, do you consider those candidates as competent to join Mintek? And for example, I'm also a master's student. I am doing, my master's is focused on the topic of optimization and economic evaluation of an extractive distillation. I am not sure if that topic is in line with what the product, with what the company is doing. Can I be competent enough to join Mintek?
Okay, Rebecca, can you see me?
Yes.
Okay, yeah. So I'll start by answering, but I think that this is also a question that Gladys can answer because it's also an HR related question. However, when I said that topics that are aligned to Mintek, what I meant was that it makes it easier that if your topic is aligned to the business that Mintek are involved in. However, when the adverts go out, they have specific requirements on job adverts themselves. So for example, there'll be requirements for, let's say, if you're applying for a graduate position or an engineer position or a scientist position, there will be a requirement of a degree. There'll be a requirement of perhaps competencies or skills. In other words, particularly for the junior positions, you'd find that they are a bit more lenient and accepting. However, for the more senior roles, there'll be more specialized requirements, meaning specifically minerals processing and stuff like that. So I would answer you like this and say that depending on the role that you are applying for, just check the requirements of that role, and adverts are posted regularly on the Mintek website. So you'll see, and then you'll see if you can fit into that. Secondly, I noticed that you said you're doing mineral economics or economic evaluations. Now, Gladys, I know that we do have a mineral economics division. So I know we're talking a lot, like in my case, about minerals processing, but there are 16 divisions within Mintek. So you need to also find out which division aligns most with your studies. And so I think that that's where I'll leave my contribution to this question. But I think that maybe Gladys can hop in and maybe explain how it affects a person who's doing a master's that's not entirely related to Mintek processes, and maybe even you can contact her for the different divisions or go on the Mintek website to see all of the divisions. Because what you've seen here is just a snapshot of 2, biotechnology and minerals processing, but there's 16 in total. So Gladys, maybe you can just wrap it up.
Right, thank you very much. I will say something to that. I think what I'm going to do, let me just, our skills programs in terms of the areas that we look at. So we look at chemistry, we look at chemical engineering, look at electrical engineering, extractive metallurgy, physical metallurgy, fuel cells, geology, and that is mineralogy, petrology, applied geology, economical geology, mechanical engineering, mineral processing, nano, science and technology, physics and precious metals, based drug discovery, and many more. But I will send this via the presentations that you get. Thank you.
Great, thank you, Gladys and Taswald. And we're going to give our first prize to Rebecca for that good question for our postgrad students. Rebecca, the PR personnel will contact you or be in touch with you to get your details. Let me get a question from Mpimo. Mpimo, you have your hands up. So go ahead and unmute yourself and answer your question. Ask your question.
Thank you, Prof. So postdoctoral opportunities and like postgrad opportunities have been stressed a lot in this in these presentations. I was wondering if Mintek does consider students or someone with just an undergrad degree, and also where do you advertise opportunities? Is it on your website, on LinkedIn, or? Oh, and last question. For say a person like myself, I'm doing applied chemistry, and we have a module called, or we've had a module called industrial chemistry, where we covered things similar to what you guys do. So is that an advantage? Is it something that you look at when you are recruiting? That's my question. Thank you.
Would that be Gladys again to answer that question?
Gladys, I think you're on mute.
So sorry, I didn't hear the question. Can you assist me?
Oh, sorry, Taswald?
Yeah, so Gladys, the Mpimo said is asking if you have an undergraduate qualification, can you be considered for employment at Mintek? And the second part of Mpimo's question was some of the modules that Mpimo has done in, I think it's applied chemistry, are relevant to Mintek, but at undergraduate level. So the long and short of it is, are undergraduates also employable at Mintek? With the current, you said that Mintek are going through a new restructuring and a new path. So where does that leave people with undergraduate degrees who want to apply?
All right. So undergraduates can only tap into either our VAC, our holiday VAC work, or as well as our bursaries. So we wouldn't, while you're still undergrad, we wouldn't, unless you've got, you've graduated and you show capability to join the workforce and we've got an available position. Otherwise, we wouldn't, recruit grads, or rather, I think not undergrads. Sorry, we would include undergrads, but not when you're at your second year or first year. Does it make sense? Does it make sense?
Yeah.
Any
also, just to add on, Mpimo, you'll notice even on the adverts will show the requirements for certain positions. And for example, in the minerals processing division, I have not seen an ad that has a BSc degree requirement. It's usually masters or PhDs. So that also guides you when you apply for the position. You will see the requirements.
Thank you, Gladys.
So what I'm going to send yourselves through the office that organizes would be the brochure, just for some information, an overview of this, the programs that we have and where you can possibly seek suitability and the next step your application towards that.
That would be great. Thank you, Gladys. So you really are encouraging students to continue with masters and PhDs because that's what the type of student, the qualification that Mintek is looking for.
Correct. That is first preference. Yeah.
Great, thank you. And I'm going to give the second prize to Mpimo. That was a good question and gave us quite a bit of information. Then Ashik had posted a question, and I think this question is for John. Why is the effluent water limited to agricultural use? John, could you share some light on that?
Yes, certainly. Ashik, I think the answer to the question is a complex one. Agricultural use is what we envisage at the type of sites that we are targeting for our technology. But that's not to say that it is the only potential use of the treated water. It's our process does not produce potable water at all. It does, though, as I've said, produce water that is fit for reuse in irrigation, and we've done quite an extensive amount of work testing it, analyzing it, and comparing it and modeling it for that particular application. But I think the true answer to the question is that it would be a case of horses for courses. If, for example, there is still mining activity in the particular area, then it may be possible for the water to be reused as processed water. It could also be perhaps used in other industries that are not mining related in the area. So I think that is the answer, that it would be site specific. We envision, though, a post-mining economy developing, with water being a central component of that, driving a new economy that is potentially agricultural based. And there's a lot of work being done, particularly by the University of Pretoria, looking at that particular application, not only for waters from our process, but from other processes. And indeed, as I mentioned, even raw AMD in some cases can be utilized in irrigated agriculture. So I think that's as broad an answer as I can give to a very good question.
Great, thank you, John. So there's potential to use that water for other processes as well, not just for agriculture. So I'm sure there'll be a lot of research going on into that as well.
Indeed, and I think it would depend on the, obviously the quality of the water will dictate what it can be used, where it can be used, and what it can be used for.
Lovely, thank you for answering that question. And Ashik, I think we will give you the last prize that we have. That was a great question. So I'd like to congratulate Tobeka and Kubo and Mpimo Ngoveni and Ashik, is it Hariprasad, I think, on those great prizes. And are there any other questions from any of the students? And I think you have you will receive this video, and I'm sure you can contact the personnel at Mintek if you have any further questions. At this time, I'd like to thank our speakers, John, Neale, Gladys, Boakye, and Taswald Moodley. You all gave great presentations and feedback to our students, and it was really good engaging with you. So thank you all. We really appreciate you spending this time with us. And thank you to our students for attending as well. I'm sure you've all learned quite a bit about Mintek. I have learned something about Mintek today. I'd like to also remind students about the next Tech Talk that would be coming up. And that's displayed on your screen right now. That's by Microsoft. So that will be a great presentation to listen to. Thank you all again. And I'd like to wish you a really great afternoon. Thank you all. Bye-bye.
Thank you. Goodbye.
Thank you.
Bye.